Good morning and good afternoon. I'm Karen Levy with Sonrai Security, and welcome to today's session where we're going to talk about, believe it or not, you can achieve least privilege in just one click. We're going to talk about a new firewall concept. We call it the Cloud Permissions Firewall, something Sonrai launched just earlier this month, which provides simple, immediate permission security across your AWS, Azure, and Google Cloud environments. And it does all of this without disrupting your operations and cloud security teams. All right, I'm the VP of Product Marketing here at Sonrai, joined today by Sandy Bird. I'm going to cover a few slides, and then Sandy's going to walk us through a demo of the Cloud Permissions Firewall. And what we're going to cover today is the current state of cloud identity security, how to achieve one-click least privilege, a quick overview of the new Cloud Permissions Firewall, and then a demo, and then we'll have time for questions and answers. So if you do have questions during this presentation, please feel free to put them in the questions panel on the right side of your screen. And as you may have heard, we're going to give away a Nintendo Switch today for the best question asked during the session. So if you want to win that Nintendo Switch, first you have to ask a question, not in anonymous mode, so we know who you are, and you have to stay on till the end of the session and reside in the US or Canada. Lastly, before we get started, the session is being recorded and the recording will be made available to all of you. All right, so when we talk about the state of cloud identity security, Sonrai has a lot of experience in this area, helping organizations of all sizes secure identity access and permissions in the cloud. And what we've learned over the years is that the current tools are just not designed to fix the volume of excessive permissions and access in your cloud today. And this slide explains a little bit about what that problem is, how big it is, and how it happens. So over on the left-hand side, we have the DevOps team represented. They're working hard, they're doing their job, building applications in the public cloud. And in that process, they're over-provisioning permissions to roles and identities in that cloud. And the result is just a massive permissions attack surface, we call it. We've analyzed a lot of these cloud environments and determined the metrics for all of these problems. An average large enterprise has over 35,000 cloud identities. So if you've been working in the cloud for a few years, this is your situation. Within that 35,000, over 20,000 in this example have excessive sensitive permissions. And we're going to talk about sensitive permissions throughout this presentation. Think about it as those permissions, such as creating an access key or creating internet gateway, something that can somehow expose data or change your cloud or provide access in a way that could be used nefariously. Completely unused identities, also a huge number of unused identities. We've seen clouds with up to 75% of unused identities. This is a huge problem adding to the permissions attack surface. And we also look at things like unused services and unused regions. So we have this massive permissions attack surface, a ton of unused identities, sensitive permissions, services, regions. They're adding no value to your organization, just introducing risk to your cloud. And then all the way over on the right, we have the cloud security operations team. They want to control this environment, but it's really difficult for them. It requires coordinating with the DevOps team, which has different priorities, fixing all these issues one by one. Maybe they have the visibility they need, but they don't have the control, and they certainly don't have the time to fix this volume of issues. So what we've done with the Cloud Permissions Firewall is we've taken a completely new approach to least privilege. We have taken this problem and the existing solutions and completely flipped them on their head. We've now empowered the Cloud Ops team to actually fix this solution with no disruption to the operations and development teams at extreme speed. And when we say speed, we've worked with organizations that have tried to fix this excessive permissions problem. One company we worked with tried this. They spent 10 months to fix 2,000 identities. They were fixing them one by one. And in that time, more identities were created. So they hadn't actually made the progress that they had hoped to. With the Cloud Permissions Firewall, in 5 days, you can bring all of the identities in your cloud, no matter how many they are, to a state of least privilege. So looking at current tools, organizations are looking to secure all 42,000 permissions. It's an unreasonable number of permissions across all 3 public clouds. And if you're working to tailor least privilege policies to each identity, you're focusing on things like list buckets, a permission that really isn't sensitive at all and you shouldn't have to worry about. But today's tool tailor least privilege policies for each individual identity. So there's thousands or tens of thousands of those in your cloud. And then each policy to deploy, you need to coordinate with the relevant team, find the person responsible for that identity, deploy, test through stage, and deploy each individually. This takes an enormous amount of time. Most organizations we've talked to have handled this for maybe a small number of human identities. They haven't touched any of the machine identities, and it's an ongoing battle. Many organizations have given up. That's why we decided to tackle this problem with the Cloud Permissions Firewall. We focus on the 3,000 sensitive permissions. We have huge experience in understanding permissions and what they can do in the cloud. We've identified 3,000 across the public cloud providers that are sensitive, so they can do damage to your cloud. We map them to the MITRE ATT&CK framework. We have a ton of content on this if you're interested in learning more. We take those and then we create least privilege policies with one global policy deployed centrally. Really what you see here is we have changed the game. Old tools give you visibility, individual policies, and you're left with a stream of tickets and actions to coordinate between CloudOps and DevOps to execute all of this. With the Cloud Permissions Firewall, we've automated all of that. It's an action tool that creates the policies and deploys them for you in the cloud. So in this slide, I want to talk a little bit more about one-click least privilege and exactly the 4 use cases or how we define least privilege across your cloud environment. And some of this reflects back to that first slide where we looked at all the numbers of excessive permissions in the cloud. The 4 use cases we talked about are restrict unused sensitive permissions, quarantine zombie identities or unused identities, disable unused services, and disable unused regions. So a little bit more about each one. Restricting unused sensitive permissions. These are the powerful permissions in your cloud that an authorized user could use mistakenly and cause damage to your cloud, or if an identity is compromised, a malicious user could do something in an attack. We have one customer who, just to keep things simple, deployed EC2 stars to all of their developers, which means that every single developer had the permission to create an internet gateway. Not a good permission for somebody to have. With the Cloud Permissions Firewall, we just remove all those excessive permissions that aren't even being used. We restrict access to them so that they can't be used. The customer we worked with, 92% of the identities that had access to that EC2 star were not even using any of the sensitive permissions. So they were just sitting there as part of the attack surface, but again, adding no value to the organization. Quarantining zombie identities. Everyone loves to talk about this one. The unused identities in your cloud. Everyone is afraid to delete these. They see it as a risk. Even if we can prove that it hasn't been used in 90 days or 6 months or even a year, organizations still don't want to delete them. They worry what will happen if it's needed at some point in the future. It can be very difficult to reconfigure it with the permissions it's needed or an access key, so they just don't delete it. Talked to one company recently, someone had been in a cloud operations role for 1.5 years and had yet to delete a single unused identity in the cloud. If you've been in the cloud for a few years, guaranteed you have this cyber garbage, we call it, everywhere in your cloud, and the problem is only growing. We don't delete the unused identities. We merely quarantine them. So we restrict access to all of the permissions of the unused identity so they can't actually do anything. I'll talk on the next slide about how we can wake that zombie back up. But the key here is we're not deleting anything. We're just restricting access to it. So it essentially can't function until you've given express approval. Similar with disable unused services. AWS today, I think, has between 300 and 400 different services. We at Sonrai use AWS. I think our team uses between 20 and 25 services. So a huge number of services are completely unused here at Sonrai and many of the organizations we work with. And again, they're just leaving risk in the cloud. So what we do is simply disable unused services. One that we talk about a lot is SageMaker. So SageMaker has a permission where you can create a pre-signed URL, which gives access to the data. Why not just turn off SageMaker in all the areas that you're not using it so that it doesn't have that risk? One thing to note here is that with everything in the cloud permissions firewall, you can deploy it at the org level, or you can deploy it at any scope in your cloud. For example, with unused services, you can look at unused services at the org level, at the OU level, at the account level, and just disable anything at any level. And similar with unused regions. So we work with one company where they don't want people in the US having access to the cloud regions in the EU. And so they just turn off those regions for the US accounts. So it's just another way to reduce your attack surface. Unused regions can cause problems with data sovereignty, or an attacker can use an unused region to go undetected for some period of time. So these are the 4 use cases that you're going to see when we get to the demo. Key message here is that we're not deleting anything from the cloud. We just put a policy in place to restrict access to the permission, restrict the permissions, disable the services, and then it can be turned back on when needed. So let's talk about how that happens. This is the zero disruption part of the messaging for the cloud permissions firewall. And there's 2 parts to it. One is when you're first deploying the cloud permissions firewall, you want to exempt everything so that every identity keeps the permissions they're currently using. And the cloud permissions firewall does this for you. When you onboard the cloud permissions firewall, it runs analytics, looks back, and determines all the identities that have been using sensitive permissions, identifies those for you, and creates this exemptions list. You can also exempt things like a break class account or build role at the top level of your cloud. So it's exempt from every single policy. So this exemptions list is automatically created. Every identity that is doing something today for 90 days or 6 months, you can put on that, is automatically put on that exemptions list, removed from any restriction policy, and then you deploy the policy. Once you've deployed policies in all the 4 use cases, your cloud is in this default deny state. So everything is protected, and new identities, as they're created, are in this least privilege mode. So then what happens? If a new identity needs a sensitive permission, or a zombie identity suddenly wakes up and needs to be used, we have this permissions on demand process. And what's great about this is that the firewall automatically detects when an identity needs access to a permission that the firewall has restricted. So you don't have to go around figuring out which policy has denied access, or who owns that policy, or who can update it. The firewall does all of this for you. So it detects when a permission is needed or attempted, and then automatically sends a message to the requester as well as an approver that's been predetermined. So all this messaging happens via chat ops. So if you use Slack or Teams, it integrates with that. You can also use email. And there's lots of flexibility here. You can time box the approval. You can have multiple approvers. You can request a justification. Lots of flexibility for how you want to manage this in your environment. The key is it happens automatically, quickly. The approver approves it, and then the firewall automatically updates the policy and grants the access back. So this is a seamless process. When you see it in the demo, it'll take seconds, up to a minute. Depends a little bit on approver availability, but the system itself automates this very quickly. You don't need to have cloud permissions to update the policy. The firewall does all of this for you. So this is the key. So a lot of times when people are doing least privilege in the cloud or any environment, they worry about these exceptions and how to handle it. The exemptions, when you first deploy, combined with the permissions on demand, really delivers this zero disruption with the solution. Okay, one more slide before we get to the demo. I know we've introduced a lot of innovative solutions and ideas here, and you probably are waiting to see it. Quick view of how we do all this in 5 days. Onboarding really quickly. Depending on the size of your cloud, it'll take us a few hours to 24 hours to digest all of the data and look back and create those exemptions lists. And then once all of that is in your cloud, you can go through and automatically deploy all the policies to get to that least privilege default deny state. And then you're in the ongoing maintenance, which is just approving permissions based on exemptions when a new identity needs sensitive permissions or a zombie identity wants to wake up. And then no doubt many people are thinking right now, well, then I've just shifted all the work from least privilege policies to approving exemptions. We've studied this as well. Some of our clients have deployed this. Maybe they have 40 plus accounts in the cloud, and they're seeing somewhere between 6 and 8 of these requests over 90 days. So it's very, very small number and a light workload to maintain this product once it's deployed over those couple of days. All right, quick reminder to put some questions in the panel as they come up. And with that, I'm going to hand it off to Sandy to show us the firewall in action.
Thank you, Karen. That's great. It's good to have everyone with us today. I'm going to share my screen. This should work. And so we're going to talk through a lot of the things that Karen mentioned as she was going through this as a real set of examples. One of the things that we found when we looked at all of these customers trying to achieve this is that the longer they were in cloud, the worse things got. You know, if you'd been in cloud for 6 or 8 years or something, the number of these, excessive permissions that were out there that were sensitive, or the number of these zombies identities that kind of grew in your cloud just continued to grow. And in all of those customers that had been there for that period of time, as Karen said, you ended up with these very large percentages of unused sensitive permissions and unused zombies. And so you can kind of take this approach where you can look at the entire cloud. So maybe in your system, you've got 50 AWS accounts and 20 Azure subscriptions, whatever it is. You've got some number of those, or maybe you have hundreds of them. And across all of those, you can choose to look at it from the top level, or you can look at a single account. And so we're looking here at the top level of this organization in AWS, which has multiple accounts underneath of it. It's not a very big one. It's test orgs, maybe has 500, but it doesn't matter. It could have 1,000 accounts underneath of it. And you can start by looking at any of these kind of use cases, as Karen said. You could start by turning off the regions you don't use. Pretty simple use case. You should know which regions you're allowing and not allowing in which zones, and you can easily go in and do that. But when it comes to unused services, you may not know what you're using and what you're not using. And what's interesting is AWS or Azure or GCP is continually launching new services all the time. Just in the time that we were building this product, there were several new services that came up that, again, our automation discovers that new service, classifies the sensitive permissions from it, and allows you to actually lock that down. And so coming into any point in that organization, you can very quickly say, okay, well, what services don't I use? If you're not doing a lot of IoT work, you're not going to be doing, IoT core. You may not use WAF regional, you may use WAF v2, you maybe aren't using control tower yet. There's all these different services that aren't using, and the system will auto detect that. It's complicated to auto detect that because you have to figure out how to map all of that and understand which places have usage and which don't. And, the scenario where, sometimes things are calling APIs to them, but they're not actually using them. But once you know for sure that these are unused, then you can go in and disable them. So the system automatically does that for you. Quick as just saying disable all unused at whatever point in the org structure you're at. You could be at a single account, the whole thing, and disable those. I'm not going to disable them here in my demo account, but you can do that. The same is true of zombies. Now, as Karen said with zombies, and this is where my mindset has shifted. 4 years ago, I really believed in let's try to get everything to least privilege. Cloud gives us this amazing audit. We'll be able to put least privilege policies on everything. With machine-based identities, you don't need that much history to build the least privilege policies. It's going to be amazing. But over the last 4 years, this reality has set in as I've watched these customers grow. And as you get to 100 accounts and 50 teams building and all of these things, the number of zombies really got out of control. Karen's stat from the first of this, 75% of identities in these older clouds are completely unused. Think about that. How many identities do you have? And 75% of them never being used. It's crazy. And so what's interesting about this is that we go through all of those and find them. We can give you a list of the zombies. When was the last time this zombie was used? And we can quarantine them. And as Karen said, why this is so important is because we're not actually deleting the identities. For the last 4 or 5 years, we've given people all the automation in the world and say, this identity has not been used in X number of months. Just press this button, go and delete that identity and clean up after it, and you won't have to worry about it anymore. Because it's in the middle of things like, lateral movement attack paths, and it has massive sets of permissions associated with it. When we ask them, why won't you delete this particular identity, whether it's a human identity or a workload identity, they often said, because if we were to delete it, we wouldn't know how to put it back. It has a set of permissions associated with it. It may be referenced in other parts of the cloud in a resource policy or something. It may have an access key associated to it. It may have a permission that's on an encryption key. We don't know if we delete that, how we would ever put it back into that place. And if that's for a really important resource, what are we going to do? And since the cloud security team sitting at the top of the cloud with 100 teams building over them is looking at, some identity with a name, they don't know if it's important or not, but they do know it hasn't been used in 8 months. So again, by clicking that quarantine button, all we do is short circuit it. It doesn't work anymore. However, if you ever need to reanimate the zombie, bring it back to life, you can do that, leaving everything intact that was there beforehand. And then finally, this sensitive permissions and excessive sensitive permissions is really important. And this is where, Karen used the example of creating an internet gateway, but there's actually, as she said, thousands of these permissions in cloud, which allow you to poke holes in your cloud configuration, expose data to the outside world. They allow you to do things like destroy the cloud if an attacker got a hold of them. They allow you to laterally move. They do things that sometimes grant additional permissions to things. These are the ones that we have to protect. But if 90% of them that have them are unused, this list of things that you're going to remove these permissions from is actually quite large. And so we can generate that list. Maybe it's 3,000, click protect and get that done. Now we realize not everybody is going to, start at the very top of a cloud with, 500 accounts and 500 subscriptions and press the magic button and say, I'm just going to remove, 10,000 zombies in one day. You're going to want to start this somewhere in your environment you're comfortable with. You'll probably pick one team in their development environment. Maybe you have a bunch of sandbox accounts. You want to start there. So you very quickly can choose that. You can also explore any account that you want because the system's actually in kind of a monitor mode by default. Now, you can choose a single service. You can choose a single account. I'm going to choose EC2 here. Very common service. It's going to be used in both accounts, obviously. And I've already got it partially protected in this environment, so I've got some protections in place. So you can go into here. One of the great things that the system does is that it finds those exceptions that need to be in those centralized policies. So as we said, we're going to block these 41 sensitive permissions for EC2. And again, we can go down here and look at what they are. They're things you would expect, like, accept a VPC peering connection. Well, if you're going to join two networks together, you better know what the other network is, right? Things in terms of, associations of route tables. So changing the actual routing rules. There's that attach an internet gateway. These are the types of things that are going to change your cloud in a way that, again, if used inappropriately, could produce a lot of risk in that environment. But the system actually discovers which identities have previously used those in the past. And because of that, it can suggest those exemptions to you and say, hey, these particular ones we're not going to actually restrict. We're going to let them happen. But the other identities which have access to these will be denied by default now. Similar, you may have a scenario that's completely unused. So if you have a certain service that's completely unused, you then can go in, of course, just disable that. And now that particular service is disabled. If you don't use, SageMaker, whichever, you can disable that from here. All of those changes that you make, though, when you apply those, go into what we call pending changes. So we're not actually changing your cloud at this point. We're just going in and allowing you to just explore everything in a monitor mode, put the controls that you want in place. And what this does is it builds a piece of infrastructure as code that you, as the customer, you own the sensitive permissions to your cloud. You go in and deploy this infrastructure as code that puts these centralized policies in place that creates this deny by default scenario with all of those zombies, with all of those sensitive permissions, with all of those unused services. And so by actually submitting this and actually doing this work, it will actually create all of the infrastructure as code that you need to do that and maintain it on your side. However, the next step of this is, how does this work once you've deployed that? So now you've put the whole cloud into this protected state. What's going to happen to that end user, to that developer, to that build role that's deploying out infrastructure that's never done it before because it's a brand new workload and maybe it needs sensitive permissions. It's been granted them, but it's never done it before. So it's not in the exemption list. How does this work? What actually happens here, if we flip over to the AWS console, is when any identity, could be a workload identity, could be a human identity. We're going to use Sneaky Jeff here in our example. Sneaky Jeff is here, and Sneaky Jeff is going to go and actually, in this particular case, change an inbound rule. So assuming that Sneaky Jeff has never done this before, they're not in the exemption list, and maybe it's an attacker trying to do something they shouldn't. When they do this, they're immediately going to be denied. And what's going to be interesting about this, they're going to be denied centrally, using a service control policy. And so what happens here is that at that exact point in time, this particular identity has been denied doing this. Now, if you've ever debugged these particular situations, they're hugely complex. You're like, well, why is it denied? Who denied it? All of these things happen. What's interesting about this is the Sonrai platform immediately detects this. So there ends up being a request that's going to go to the team that needs to approve this. If it's a workload role, if it's a human, it'll be sent directly to the human, asking for justification of this or the approval of it. And so we're going to use a scenario here where we're actually just going to approve Sneaky Jeff for doing this, hit approve. And then what actually happens here is back in this create security group, they would get a message back using whatever mechanism they're using, Slack, Teams, email, whichever. They go and do the exact same thing they were previously doing. And within 1 minute, that's actually going to work. And so all of a sudden, this disruption that happens from, oh, I need these certain permissions. How am I going to get them? I'm building this workload. I don't know how to give the permissions to the workload. If teams over permission stuff, which was what happens when things don't work, and then all of a sudden, everything you're deployed with ends up with, as Karen used, EC2 star, Lambda star, contributor in Azure, editor in GCP, and these very over permission things, because it works. And then it gets rolled out to prod and you can't get it back. This allows you to protect all of those by default, since 92% of them never use those permissions anyway. And rather you're doing those in exceptions or the actual approval process in Slack or in Teams or in email or however you do it, it gives them back these permissions within a minute of them actually trying to use them. And that's actually the thing that our design partners, as we were building this solution, had such a reaction to. It's great to put the centralized rules in. People will say, well, I know how to do those things. I can do that. And they'll say, okay, well, exemptions are a little hard, but we could figure out how to build a list if we spend a lot of time figuring that out. But what happened on day 2, after you put the centralized rules in, how did you give back the things that got blocked? And using these permissions on demand process allows you to do that. Not only that, it allows you to wake those zombies up. So when a zombie all of a sudden, after 8 months, decides to run its report, and for some reason that report needs to have one of these sensitive permissions, it will just request of the team that owns that workload, do you need to wake this identity back up to do this? They hit apply and they're done. So again, it's pretty easy actually for a team to actually continue to build in their normal way. So nothing really changes from their workflow, but all of a sudden the amount of sensitive permissions and unused identities and all of this risk from identity just gets swept out of your cloud within a couple of days of doing this. And so we have a kind of an interesting free trial option for people that are interested in this. And one of the great things that you can do is you can go to, HTTP Sonrai security/trial, and you can actually try this whole system out for 14 days. And what's really interesting about trying it is it goes in monitor mode by default. So you get to see all of the exemptions. You get to see how many zombies you have. You get to see how excessive your sensitive permission layout is. And you can try this kind of chat ops flow in a corner of your network that's low impact. You can try it with a dev team and you can see the reactions of the team. Do they love this? Is this much better than, trying to create some sort of a ServiceNow ticket to get access to an account for an identity that doesn't even exist yet? All of these types of things. They can just go about their regular work, do a few of these approvals and get this done. So with that, Karen, I'm going to stop sharing and hopefully we have some questions to answer.
We do. I love presenting on this topic because people always, their wheels churn and they come up with some really good questions trying to figure out how this all works. So we're going to do our best to answer those. Remember, a Nintendo Switch is up for grabs. Put your questions in and we will judge for the best one at the end of the call. I'm just going to pick a random one here. How are the zombies, love that terminology, we do too, quarantined? Is the IAM policy flipped from allow to deny or the trust policy modified? Over to you, Sandy.
Yeah, so there's a couple of ways we do it, and it depends on the type of zombie, how that's actually done. But you can think about it this way, and I'll use this in terms of AWS, although it's similar in GCP and how it's done. Basically, we can create a way to deny anything in AWS using SCP, so you can basically remove the possibility to do that. You can just deny star. But the problem is that you can't, if you know anything about SCPs, you realize you can't actually do that for this because you would run out of space. And so what you need to do, and AWS and GCP have this lovely benefit of being a deny first model where you can take the identity and attach something to it that basically says deny star. And what happens is no matter what policies have been allowed on it and all of these things, it'll never be able to do them. However, we can catch that, and when they do try to do something, then we can remove that and all of the rest of the permissions stay. And so there's a huge, huge benefit in doing this to be able to clean up this mess without actually removing all of the permissions and all of the configuration and all of the things that have been done. But even if you did that, again, I always tell people you could do this yourself today. There's ways to do this. The problem is the waking them back up. You need to basically wire it in, figure out, how to know when it's trying to be used, so you can tell the team, it looks like your report thing just woke up. Do you need this thing to run, and go from there.
All right, let's keep going. Sandy, how quickly does your solution adapt to new AWS offerings, features, updates, etc.?
Yeah, so Sonrai Security's been at this identity permissions monitoring / getting to least privilege for years now. So we've had a process in place where, as any of the cloud providers roll out new permissions, or they roll out new services, or they change the way those permissions work, or they change the way that they're audited, we're always keeping track of that. There's a couple of interesting things that happen there. If you're used to the clouds, stuff often rolls out in like preview modes where it has one name, but then when it goes GA in the clouds, it has a different name. You also will notice things, if you pay a lot of attention to this, some of the APIs show up early before public announce. And so with Sonrai, we actually get sort of that early trend of things. So we get to see the public API releases or the preview API releases in their code names. That gives us a sense of what permissions are coming. Then when they actually get publicly announced, we have a way that goes in and finds those new permissions and those new services. We update them on our side, and then the customer updates them from there. What's neat about this solution is that in a scenario where, let's say, there is a new sensitive permission that comes out or something in those services, it's as quick as just pressing that button at the top that redeploys changes, and all those things get in protection mode by default and go into that deny first state, which is quite nice. There's a couple other things that happen there in terms of new things being detected. We're able to actually educate you a bit too into new things that are showing up and what the risks are around those, and we can use those same cloud ops channels or chat ops channels for doing that.
Great. And then we have a question from Ed talking about smaller organizations. So how customizable are your security solutions for smaller businesses that might not have the resources of the larger enterprises? Can you give an example of how you've tailored for SMBs?
Yeah, this is kind of an interesting one, and it's one where my mindset kind of changed over years of time. So when we were thinking about this solution, we were really seeing a pattern in our own customer base where the very large, very mature, highly funded enterprise customers could actually get things to least privilege. But they often had teams of people that were monitoring it and shuffling the tickets out to the teams and then monitoring to make sure they did the work. Some of them had several people that were responsible for just writing, SCPs in AWS or writing Azure policy in Azure. And so they had these big teams of people that could actually achieve close to least privilege. I don't think any of them would say they ever got there completely, but they were actually making massive progress. But when we looked at the small, medium businesses where, there were a couple security people that basically ran the cloud infrastructure with some development teams underneath of those running wild, they had almost no control and no way to get to least privilege. They could generate least privilege policies. They could put them in a JIRA ticket and say, you have to change this, but no one was actually doing the work. And so when we built the solution, we were trying to take some of the practices from those really high-end enterprises that were really good at this and say, how would you scale that so an SMB could do it in a couple of days? And so what's interesting about this cloud permissions firewall, unlike deploying a cloud infrastructure entitlements management product, this thing really does take almost no staff to run. You basically put it in place, you configure it at the top level, and when it's in, it's in. And then all of the work actually immediately floats down to the workers that have to do the approvals. And so setting up your approval process, which you also have some pretty neat intellectual property and figuring out who owns which workload and which account, that all happens in their level. So the two people that own the entire cloud infrastructure are no longer bottlenecked trying to figure out how to write these SCPs and how to operationalize them and how to build these privilege policies for everything. So this actually works phenomenally well for an SMB. It also works for large enterprise because they also have struggles in some of this stuff as well. But it is really a solution that a small company, maybe with 10 or 15 dev teams that are building, some number of these applications, can get this thing under control in a week. So you can try that 14-day trial, and halfway through that trial, you're like, wow, this thing actually works. And I actually feel like I've removed massive permissions risk out of my cloud in a week, which I've never done in a year since I've been here, or however long they've been working at the company.
Yeah, and I would just add to that, we've soup to nuts, we've thought about large to small organizations, and even the pricing is designed to scale down for smaller organizations. So there's more information on our website, but we did a lot of market research and early access on this product and heard loud and clear that smaller organizations want this. So we've thought about that from the go-to-market as well. Another question about the approvers for permission on demand. How are the approvers defined by the permission for the permission allowances? Can the request be integrated with any existing systems like an IGA that may have approvers already defined?
This is one. The building of this product was fun. We had a bunch of design partners. We did a lot of interviews with different companies. We did a lot of stuff. And in the early days of this, Karen will remember this. You're pitching off some slides in a mock-up in UIs, and so you get a lot of these questions like this one, which is like, well, how does this work with SailPoint? How does this work with Savient? How does this work with Delinea? Whatever it is, you're using these other tools for things in your system. What's neat about this is, and you have to think about it in two ways. One is, this is actually cleaning up a mess that those products have already put in your cloud. So everything that's here has been approved by somebody or created by somebody. We didn't add any new permissions. We didn't grant any new permissions. There's nothing that we did using the Cloud Permissions Firewall that gave anything to anybody that they didn't already have, or any workload that it didn't already have. This is very much a layer of control on top of the mess that has already been created. But then you say, okay, but now I run this thing for 5. So in that scenario, you don't have to even integrate with those products. They just do what they do. This doesn't get in their way. And there'll probably be a sensitive permission, by the way, if, as an example, SailPoint actually provisions administrators into permission sets in Identity Center in AWS, then that's going to be a sensitive permission, because it's going to need permission to do that. And it's going to have an exemption in the Cloud Permissions Firewall to do it. However, fast forward, now you're using this for a period of time and you truly trust it. And you're like, wow, this is actually the control on top of all of my permissions that are laid out in the cloud. Now I actually want to have some form of, process around this. Maybe I do want a Jira ticket, or I want developers to ask up front before they get them, and those types of things, so they can be approved before they roll them out. Everything in here is API driven. So as long as you have a requester removal system of some form, you can create those API calls to actually integrate that into the system as well. And so again, one of those other tools, an IGA tool that can make a request to a system like the Sonrai Cloud Permissions Firewall with an API, could ask for those exceptions for an identity as part of that process if you needed it to. The question is, should you do that, knowing that the way that has worked to date is 92% of the identities that got those sensitive permissions never ever used them, right? So again, decisions to be made there, but generally speaking, on day one, this isn't adding permissions. So you probably don't even need approvals in those systems for this. It's layering it on top.
Can you just, Sandy, also touch on how we determine approvers in the system? I think it's related to this question.
Yeah,
we're going to do speed round. So we're going to speed round these questions now. We've got a bunch coming in. So
okay. So determination of approvers. Like I say, we have some really interesting intellectual property where in our current CIM product, we can detect, we'll call it sensitive access to different workloads in different areas of your cloud. And we get that through lots of different ways in each of the clouds, and every cloud's a little bit different in how it's done. And then we've seen a lot of cloud infrastructures that we learn things, and I can give you one of the simplest tricks. If you find somebody at the top of the org that has basically, security auditor or read-only across the whole cloud, highly like they're one of the people that are probably supposed to be the upper level approvers for things, because the reality of the situation is somebody's granted the visibility everywhere, right? And so those types of things we use to basically find who those approvers are. But we know we're always, that's a great starting point, and it's a great way, if you don't know who they are, to have a target list. You may need to override that to the point. The things that actually you need to be approvers may not have access to the cloud at all. It's quite often that the product owner or the ops people will all have access to the cloud, but somebody that's actually running the program may have to do some of these approvals. That's okay. In the system for the Cloud Permissions Firewall, you can just bring up the approvers part, go to that area of the cloud, and override those approvers. And there's a whole bunch of interesting workflow in there and doing that in bulk and making exceptions for it as you go. And it supports 2 work modes. I think one of the most important ones is it allows for self-approval in the areas of the cloud that are probably non-sensitive to you, right? Sandboxes, dev accounts, whatever, let the developers run. They run the thing, it gets stopped, they approve it themselves, they continue their work, there's zero disruption in that completely. As Karen said, though, if you don't want self-approval, you want somebody up-chain to do it, well, now we can send the request to them immediately. This particular workload identity was just denied in doing whatever. Joe's blocked on his work. You need to press approve at this upper level. Hopefully that happens super quick because a person's watching Teams on their phone at lunch and presses the button and says approve. But as soon as they do that, you're back in business. So you can do self-approval in the areas that you would allow that. And then you can have kind of an escalation style approval for areas that you don't. If that approver does not approve within a period of time, it actually self-escalates up the chain to find somebody who will press the button or deny it and say, we're not allowing this to happen.
Unrelated question, is there a time limit on the permission requests?
So yeah, they're time boxed. So when you actually go in and you grant these and request them, you can actually suggest what the time window that you want, and then the approver can override that or change it. So it's an interesting thing. Again, back to our design conversations in this, you always think about the time boxing as a just-in-time feature. You call this a just-in-time product, but it is one of those things that's doing that. It's giving permissions at request time. You would have never thought about that for things like workload identities, but it's possible to actually do it for workload identities in this scenario. And if you have like deploy windows that open up where you can make changes in that window, you absolutely could even allow workload identities to have those time boxes.
All right, thanks. Remember we had the question about how do you learn about new things popping up in AWS? Can you touch briefly on the same for GCP?
Yep, very similar questions. We interrogate a bunch of the GCP APIs to figure out what all the possible permissions and all the possible services are for doing that. We have a bunch of other things that we do there too. There is a difference in GCP versus AWS in terms of, we'll call it the way that permissions are defined. GCP has a fairly clean model where there's no such thing as wildcards. And so you can't actually say, BigQuery.create star in GCP. It doesn't exist. So every single permission is unique in nature, and it's defined in the roles when you do that. AWS is not so clean. So AWS uses star permissions all over the place in their model definitions. And so we actually in AWS have to expand the stars out to all of their individual permissions to understand if the new permissions that are coming in would interact with any of the existing rules and all that stuff. You don't actually run into that problem in GCP. The process is similar though. There's, again, in all of these clouds, there are ways to interrogate them for all of the permissions. And then there's just a lot of testing to do. Once you have the permissions, you have to figure out if they're sensitive or not. People always say, oh, it's super easy to figure out if something is sensitive or not. Well, that's not so true. You use the example of the IAM service in AWS, and you can say, well, anything that's a create star must be sensitive. But it's not. Create user, create role, create policy, those are probably fairly sensitive. But create credential report actually isn't, because it's just generating a same thing as kind of list and describing the things that are happening there, right? And yet it still uses create at the front. And there's thousands and thousands of these examples where the permissions are just not named in a way where you would understand what's sensitive and what's not sensitive. So.
All right, question, excuse me, related to free trial. Someone here, Ezra, has a sensitive security posture. Can we do an NDA and delete all data at the end of the trial?
Yeah, absolutely. Again, Sonrai Security for years has been doing trials in the CIM space, and we have a whole process for data destruction, and we can send you a little certificate at the end that you can put in your compliance reports to say all data has been removed and all of those things. So.
All right, another question about ecosystem. Are there integrations with cloud risk platforms, thinking Wiz and Orca, that would facilitate expedited remediation of findings?
So it's an interesting question. It's a very interesting question. The expediting of remediations and findings, there's nothing to remediate. Deny by default. You're not having to fix anything. You press the button, you're done. No tickets. No developer gets a ticket. Nobody has to roll anything out. No one has to change anything. It's done. So from that perspective, you don't need to worry about it. However, and this is where it gets really, really interesting, those products are all detecting over permission states, right? So they're also saying, oh, well, we noticed an access analyzer says you should have this better policy. Some of them are generating those policies themselves. They're looking for things like lateral movement, like this identity can exploit this trust relationship in this other account. What's interesting is when you put this in place, though, many, many, many of those tickets sitting in Wiz or Orca or whichever you're using should just go away. Because all of a sudden now that identity, which was unused, is now denied from doing anything. So it has no permission. So it's of no risk. That means it can no longer laterally move. It can't execute that trust relationship. That role that was unused that had a trust relationship that's now unused can't do that. All of those things that the sensitive permissions, that 92% risk that collapsed, should automatically close all of those tickets off in Wiz, Orca, or whatever you're using. And so the integration isn't direct, but it happens through them actually analyzing the cloud and analyzing the changes that are happening and collapsing that risk for you, saying, hey, all these problems that we thought were problems are no longer problems anymore because you've removed all of those permissions from all of these identities.
All right, we have 2 questions related compliance. Compliance is on the mind. So can you ensure compliance with HIPAA and GDPR when handling resources? And I'll ask the second one. With increasing global data privacy and security regulations such as GDPR and CCPA, how do you help ensure compliance across multiple jurisdictions and cloud environments?
So compliance, there's probably 800 rules and regulations to each one of those, and there's probably 800 questions as you go through all 800. But we'll give the high level, and then you can dive into it. In all of those compliance regs, whether it's GDPR or HIPAA or PCI or pick your poison, they're all based on some set of things. They all have a least privilege component into them, and this absolutely is a control that helps meet those compliance regulations. So that's one. It also has, this product has great reporting, so you can see what the exemptions were made and who made those exemptions. So you have great audit for when you have to do your compliance audit at the end of the year for any of those. So that's part of it. So we'll help there. The other thing is that some of these controls can be used to control those regulations in the cloud. So not all services in AWS, Azure, and GCP are approved for things like healthcare workloads under HIPAA. And so you can use these controls to turn those off so no one can accidentally use them, right? And there's good reasons why some of them are approved. Some of the logging standards aren't up to where they need to be and things like that yet. And so you certainly wouldn't want to be using those. So those can help control that so you don't end up with an accidental audit finding at the end of the year discovering that you're using a service that's not approved. The third kind of part of this comes into some of that region work that Karen mentioned. And it's one of those things that you should know which regions you're in and where your data is supposed to be and all of these things. But what we find is these accidental scenarios of, hey, this team sitting in Europe, ends up with help from the US team doing something, and somebody says, man, we want to run Athena, or we want to put all that data in BigQuery, and they move it to an account that they're in with their workload doing something, and all of a sudden the data's in the wrong spot, and it should have never happened that way. And so some of those region controls can help that. We find most customers to date have spent a lot of time deploying region blocks at the top of their cloud. So they go at the top of the org and say, well, we don't use these particular regions, and they turn them off. But they don't look at it by a leaf node by leaf node scenario. So the team in Europe, probably those accounts shouldn't allow US regions, and the team in the US, they probably shouldn't allow the European regions. And so the system allows you to do that at the leaf nodes of your clouds, at the single account levels, at the single subscription levels versus the top level. And so it's a more granular control than you typically would get in one of those solutions.
Great. Wheels are churning here. People are thinking about their dynamic cloud. So here's a question. Will Sonrai make notification if an AWS workload or container permissions are not locked down, basically open to the world? Is there a notification that basically says you need to verify permissions for newly created containers?
So we're using the word AWS and containers can be Docker containers. They can be S3 buckets. There's like a whole bunch of You have to kind of drive that down to specific resources. But let's break it down into a couple of things. One is all new permissions getting granted to IAM users, IAM roles, SSO users, whichever it is, are being controlled. However, in this particular solution, we are not controlling, we'll call it resource policy permissions. And so if somebody in your cloud goes to, and we'll use the simplest example of an S3 bucket, and puts a principal on it that says, allow star permission to principal everybody in the world, then everybody in the world can do that. We have another product that has an alarm on that you might want to look into, but that's not what the cloud permissions firewall in this case is. This cloud permissions firewall is about those sensitive permissions. It's about the users that are in your cloud and those types of things. It's not the one that's the public bucket detector. Now, that said, let's go back to the other side of this, which is, that container that's sitting there running in EKS, or, that side of it, those resources that are being deployed, the S3 bucket is not public, but is controlled in the cloud. A lot of times these identities that we talk about from a risk perspective have the ability to manipulate those to make them public, have the ability to manipulate them to poke a hole in the firewall, have the ability to manipulate them to create a pre-signed URL for it. Azure has this great one where you can take the file system of a disk and make it a URL on the outside world. Like, who thought that was a good idea? But you can do it. These sensitive permissions are the things that make that happen. And so while we're not detecting it, what we're doing is the first time somebody tries to make it public and they've never done that before, bang, you get a permissions on demand request saying, did you want them to approve them to change that resource policy? Did you want them to be able to actually create that URL of that file system, whatever that permission happens to be? And so there is a massive protection in this product that stops that from happening in the first place. But it's not the one that, if you've been in cloud for 5 years, we're going to crawl through all of your buckets and find out if they're public or not. Go use your CSPM for that.
All right, I think we're going to do one more and then pick our winner. I love this question, guarantees. So how is this a guarantee of the security of critical permissions? Love people looking for a guarantee.
Guarantees.
Security.
What's nice, and so I will separate my clouds again because clouds are different. AWS and GCP, guarantee, deny wins every freaking time. So if there is a policy at the top of those clouds that we put in that says deny attach role policy, it will be denied. Deny act as in GCP, it will be denied. It just is that they other than, otherwise you got to go back to Google and AWS and say, why is your own engines? This is what's interesting with the cloud permissions firewall is this is not something that's in line. It's not something we put some weird man in the middle that captures every API call and changes it. This is laying down cloud native controls at the speed of cloud and however they operate. It's just controlling the cloud backplane as it exists today. It's brilliant for that. It works because of it. Azure is slightly different. Azure is an allow first model, meaning that if anything granted you the ability to do it, then you have the ability to do it. And so the way that the system works in Azure is slightly different in that it's manipulating these. But if you're acting at a small edge of your cloud, and we will have visibility into this, and something above it is granting that ability, at the edge, we won't be able to stop it from happening. We will be able to inform you that above this, there's another control allowing this to happen, but there's no guarantee you can stop it at the edge unless you move up the ladder to a higher management group point to actually fix the problem. So again, guarantee, AWS and Azure, it's guaranteed, or AWS and GCP is guaranteed. In Azure, there is a bit of a caveat. You'll have visibility into it when it's not. You'll know that, but the reality is it has a whatever. There's an exception to that rule.
Thank you, Sandy. We're going to wrap with that question. Be thinking about your favorite question. As I remind folks, free trial available. You can test it all out in your environment. We just require read-only role access to your cloud. And if you want more information, go to sonraisecurity.com. You can get a customized, tailored demo, ask more questions. And if we didn't get to your question, we'll certainly follow up with you. Thanks, everyone, for all the great questions, participation, and attention today. Sandy, did you have a favorite question?
I knew you were going to ask me. I'm like, I was answering the
Hard
question.
to remember all of them.
I wasn't remembering the one that was my favorite. I love the word zombies. Whoever says zombies gets a plus on that one. I like the zombie one. And and I don't have the questions in front of me. I have a few of them.
That's fair. I think I like the one where we're talking about other cloud solutions because we love to separate ourselves from the Wiz and the Orcas. So William Vu, I'm going to declare, great question about integrating with Wiz and Orca and expediting findings and how does all this stuff work together? Because we really believe there's a lot of things to clean up in your cloud. We believe the firewall is a great way to get started, but integrating and working with other solutions is key as well. So we'll get back to you, William. And thanks everyone for participating. And we'll be continuing this series. Thanks, Sandy.
Thank you. See ya. Bye.
Bye, everyone.